Hi, here I am presenting the architecture of my AI-powered recruiter assistant integrated directly into my portfolio, and either by typing or speaking, you can innocently learn about my skills, projects, and experience. On the top, we have portfolio site, which is hosted by on GitHub page and connected to my custom domain, ajmalamir.com. Inside the website, we have an embedded AI Ajmal AI widget, which works like a chatbot. Recruiters can ask questions either by typing the question or using the voice conversation, and gets instantly response about my background. And here we have a voice instruction layer. This part is the assistant also supports a real-time voice instruction. When recruiter press the microphone, a voice overlay appears. The browser speech recognition converts the voice into text, and then the transcript is then sent to the backend like a typed input, and then the backend here all user questions are sent to my backend server built with a FastAPI deployed on a railway, and the backend expose two main endpoints, chat and TTS. Chat generates AI responses and converts responses to speech. The backend also use core middlewares to securely allow my portfolio website to communicate with the API. Then we have our RAG, which is the intelligence system comes from the technique called Retrieval-Augmented Generation, or RAG. Instead of giving generic AI answers, the system first retrieves relevant information from my documents, which process my resume, project description, and profile information are stored in a text chunks. These chunks are indexed using FAISS vector search, and when a recruiter asks a question from here, the system finds the most relevant piece of information using the RAG, and only those piece of information is processed to the AI model, and this ensures response are grounded in actual experience, not hallucination. So then we have our LLM. The retrieved information is sent to the large language model. The model generates the answer using the recruiter question from my retrieved portfolio data response formatting rules, and so the AI answer like a recruiter assistant, not a generic chatbot. Then we have a voice generation. The voice generation response is generating a text to answer. The system optionally converts the response into speech using 11 labs. The audio is returned to the browser using the base 62 MP3 and played automatically, allowing a natural conversation experience. So this is the whole architecture. Overall, the flow is recruiter asks a question, front end sends request to the backend, and backend retrieves relevant data from the knowledge base, and AI generates the answer. Answer is returned back. Optionally, voice or playback happens, or a text, and it creates a real-time intelligent recruiter assistant embedded directly into my portfolio. So now I'm going to show the actual portfolio website where is the AI chatbot is embedded here, and here we are typing any question. For example, who is Ajmal in one line. Okay, so there we go. So the information is coming right here, and you can want more detail or chart, so that's up to you. Then also you can use the voice, you can click on the mic.
Hi, you can ask me questions about Ajmal's projects, skills, or experience.
Please explain one of his best projects.
One of Ajmal's best projects is the Dental Clinic Management System. This project involved designing and implementing a complete relational database system to manage various clinic operations, including patients, appointments, treatments, billing, staff management. It features normalized schemas, optimized queries, stored procedures, triggers, indexing, and transaction handling to ensure performance and data integrity in real operational environments. Sources, projects.
So that's it. So this is the project. I'm going to explain the code in very short. So this is our main function, which is used to communicate with our front end and back end, which is calling the API from the backend and passing the information in between to the chat as well as to TTS, and which is voice or speaking, and here, and the rest of them are all this part is our actual chatbot, which is right here. And then once the information is communicated between the backend, it goes here. So in the backend we have used FastAPI, and also we have used core middlewares from the FastAPI. And this part is loading our RAG, and it stores fast in chunks. And this part is requesting response models, all of them. And this is a helper to call OpenAI chat API. Then this is the chat endpoint, and also the TTS endpoint. This is used for making sure that the system works and the backend works actually in a real way, for checking its health and make sure it works if we need it. Then this is the RAG file, where the RAG file is used for text embedding to small. We call this is the LLM model that we're calling. Then we have this the class of the RAG, and here we have the constructor for the RAG. Then we have some functions. So this function is using the fast expect batch vectors if the batch size is 1. And then we have here we are finding the top k-similar chunks using this part. And then this part is also extracting first URLs, because URLs are not kind of unsecure. That's why we use this part to retrieve the URLs. So this is the ingest.py, which this part is it builds scripts, the knowledge from knowledge index for our voice bot. This is all the imports, and this is the configuration, where we all call the storage and the knowledge directory. And this is where the file is where the FAISS index will be saved, and this will also file where the chunk text and source will be saved to the disk. And this is our file readers, reads our files from our folder. It's also file reader, and this part is loading our documents from these sources. And this is chunking, so it splits long text into smaller overlapping chunks, and it's very important. This is embedded texts, so converts a list of extra into embedding using OpenAI embedding API. And yeah, so this is a mini script for ensuring the storage folder exists and solving and so saving it doesn't fail, all these stuff. And this is the output once this file is run and all these chunks and embedded data is saved to the storage. So yeah, that's all. That's the whole code and everything. And if you have any questions or suggestions, please send it through this contact me form, and you can put your name, your email address, and your feedback, and I will receive it through my email. And then again, thank you for watching. Thank you so much.